Okay, troops. Oh, that's the title it suggests. This is chapter 1, homework problem. It's the last problem. It's so-called bridging problem. So, I suppose what I could do is, let's see. So, let's get this for a sec. And so you're presented with this picture. And it's a little confusing looking because of the way they put the X and Y axes. And in fact, when we actually do these kind of problems, I'm going to show you how to set them up differently, but we have to deal with the problem at hand. So basically, the solution is to draw your X and Y axes, that's the blue lines, and put it right at the tail of the F vector. Because at the end of the day, this is a vector component problem. So then, you have, and they're asking you in part A about the weight. So for part A, you have three things going on at first. You have F itself, you have F of X, and F of Y. So now you look at this here, and you notice how, you look and see how I got F of X and F of Y. I just have the vector F, and I drew the perpendiculars. And just like any basic, we're used to seeing it like this. And then we have our perpendiculars like this. But this vector is in the quadrant. Well, it's kind of weird. It's not exactly in quadrant 3. It's actually in quadrant 4. It's like we're looking at the back of the XY axes. But it really doesn't matter. I mean, they decided to define X and Y like this, right? And so, see how I've got the arrow up here. But probably we don't have to worry about pluses and minuses, but in any event, let's first just get the magnitudes of these things. And, well, even before that, we'll back up even more. We need to figure out what it is that we're asked for and what it is that we're given. So we look up here, and one thing you have to notice is that we're given that we're allowed to have a maximum perpendicular force of 425. So we look at this, and you have three force vectors to choose from. Which one of them is at right angles to the roof? Right? Ding, 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 ding. So this is the number you're given. Which one is the weight? Well, remember, your weight vector points straight down. So this is the weight. So now, you know that sine and cosine are involved here. You have to decide where to put theta. So we know that this thing is at a certain number of degrees to the horizontal, and this we've decided that the x-axis is parallel to that. So if I draw this horizontal dotted line here, this should be familiar from geometry class. That means that theta goes here, because that's what we're given, right? Next, we know that if we go to I forget the title for this, not alternate interior angles, but we know when we have two parallel lines, these opposite angles are equal. So the angle in here is also theta. Now here's the trick, and again, this should be familiar. The angle between the dotted line and F, by definition, is 90 degrees. All right, so the dotted line and F is 90 degrees. So that means that that angle is also got theta in it. So that just means at the end of the day that the angle between f of x is 90 minus, well, it's not going to show up so well, 90 minus theta. And because f of x and f of y by definition are 90 degrees apart, this is theta. Now, part B is that you've got to remember that f dot s is f dot s equals to f magnitude, s magnitude, and times the cosine of, we'll call it phi, the angle between f and s. Now, in this case, your s is L. And then F is from part A. And the angle between F and S, or L, is on the drawing there. I'm not going to point it out to you. I'm going to leave it to you to figure out. Okay. See you soon.